Hello. Welcome to this recording of A Start Maths Lecture 4. For now, no one's made it into the meeting. Hopefully, one or two people will turn up soon, so I won't just be talking to myself and to YouTube. But what we're going to do today, regardless, we are going to go through some of the skills to do with numbers within the A Star exam. So to do numbers in an hour, obviously you're not going to be covering everything. It's quite a big topic. There's a lot going on with it along the way, but we're going to cover a few of the key areas, things which are worth pointing out, things which could potentially be useful for, and so people can build on it. So the first skill I am going to go through tonight is just long, so multiplication. So we'll look at multiplication, we'll look at a way to do long multiplication and a few important tips. So first we're going to say key tips with so actually what we will do first, we will look at long multiplication, and in particular we're going to look at the grid method. So at school, probably most of you learned the column method for multiplication, where you put one number above the other, and that's perfectly valid method if you feel confident with it. But I know some students of mine have really struggled with this, so I'm going to show a method called the grid method, which you can use in this place. So say for the grid method, if you have 327 multiplied by 64. And so how you would take on this question using the grid method is a split the number into parts, creating a grid. What I mean by splitting a number into parts is every number within a number has a value. And you might get this on a numbers value question at the start. So 3 is in the hundreds, so the 3 is worth 300. 2 is in the tens, so the 2 is worth 20. 7 is in the 1, so it's worth 7. Or equally is 64. 6 is in the tens, so it's worth 60. And 4 is worth 4. So it's splitting a number into parts, basically. So where we've got 327, we can write 300 here. And we can put 20. And then we can put 7. So splitting this number into its 3 parts. And then on the other hand, when we've got down here, we've got a number 64, we can do 60 and 4, so split it into 2 parts. And so now we've done this, all we need to do is fill out the grid, multiplying the single digits and adding the zeros. Because in effect, we've got to do 300 times 60. But what 300 times 60 is, it's just 3 times 6, which gives us 18. And then plus 3 zeros, so it gives us 18,000. We've got 60 times 20, which is just 6 times 2, plus 2 zeros. 60 times 7, which is 6 times 7, this gives us 42, plus the 0. 4 times 300, so 4 times 3 plus the 2 zeros. 4 times 20, so 4 times 2 plus the 0, and 4 times 7. And see, now we have done this, we can see, write the numbers in a column from biggest to smallest, making sure to line up the digits and their values correctly and add them together. Okay, so here we've got 320 times 61. Well, we've done that bit already, but here we've got our numbers, so we can do our 18,000. Then underneath we've got we have got our two 12,000s. We've got our 420. We've got our 80, and we've got our 28. And that's just a case of adding them together using the column method for addition. So zeros plus 8 equals 8. 8 plus 2 plus 2 equals 12. So we put 2 here, 1 in the next column. Then 4 plus 2 plus 2 plus the additional 1 gives us 9. 8 plus 1 gives us 10. So we write a 0 here, have a 1 over. And finally, 1 plus the 1 below gives us 2. So we've got a final answer of 20,928. And so you can see that this grid method, it can be one really worth trying if you've always struggled with the column method, just because it's got less steps to it along the way. All you have to do is draw out your grid, multiply the numbers, add in the zeros, add the numbers together. It's pretty simplistic, I would say, in regards to the more traditional column method. I mean, there's nothing wrong with the column method, as I said. I'd probably end up using it myself because it's what I grew up on and what I've always used. But if it's something you struggle with, I'd really recommend trying this method. All right, we're going to move on from that. And the next thing we're going to have a look at is in terms of the vision. So bus stop method. I've never really understood what it's called, a bus stop, but this is what we call it. But say if you've got a question here, let's say we've got 3, 2, 7, 5, 1 divided by 3. And so all you do is you put the number you're dividing by, so the second number outside the bus stop, and you put the number you're dividing into, the one you're dividing, inside the bus stop, and then you just work your way from left to right. So you do 3's into 3 goes 1. 3's into 2 doesn't go, so important. You write the 0 and you've got 2 remainders, so that goes on to the next number. 3's into 27 goes 9. 3's into 5 goes 1. And then you've got remainder 2, and 3's into 21 goes 7. And so you've got a final answer of 10917. So we'll just call this normal bus stop. So hopefully that's reasonably familiar. If it's not, try and look some up and practice them. So these are all the stages. The number you are dividing on the inside, the one you're dividing by on the outside, and then work from left and right, putting remainder onto the next term. So next we're going to look at below just how to turn remainder into a fraction. Because generally in the exam, just writing remainder 2 or something, it's deemed as quite infantile. It's probably not going to be accepted for an answer unless you were specifically asked for it. So say if you've got a question, let's say we've got 5461 divided by 12. Well, we would put 12 on our outside and 5461 on the inside as before. So 12's in a 5 doesn't go, so the 5 goes over. You could write a 0 here if you found it easier to, but the 0 doesn't mean anything, so I'm not going to. Now 12's into 54. You might be expected to know the 12 times table. If you didn't know the 12 times table, you can always note it down at the side and work your way to like adding 12 each time. As it is, 4 12's are 48, then 54, take 48 is going to give us 6. So we've got remainder 6. Then we've got 12's in a 66. Well, we've got 5 12's equals 60. And so again, we've got 6 left over. And then we've got 12's in a 61. Well, 5 12's equals 60. and we got remainder 1. So to turn the remainder into a fraction, we simply make it the numerator, so the top number, with the number we are dividing by as the denominator, the bottom number. So in this case, we've got remainder 1, so it would just be 1 over the number we're dividing by, which is 12. So our final answer will be 455 and 1/12. Okay, so hopefully that makes some sort of sense along that, and it's a simple trick. If you're not asked in what method to write your remainder, always write it as a fraction, because writing as a fraction is the easiest method. But you could be asked to write as a decimal as well, which we're going to look at. What I would say as well, if your fraction at the end can be simplified, for example, if there had been 3/12, you could then simplify it to 1/4. We're going to look at simplifying of fractions next week in that specific class, but it's important to note that as well. So what we're going to look at next is giving the remainder as a decimal. So the question would start exactly the same as before, but you may be being asked to give you a remainder as a decimal. So let's say we've got 3725 divided by 4. Okay, so again, we are going to have our 4 on the outside. We're going to have 3725 on the inside. And so what you could do here is 4's in a 3, doesn't go. So I've written a 0 this time. As I said, it doesn't mean anything, the 0, but just in case. 4's in a 37 goes 9, remainder 1. 4's in a 12 goes 3. 4's into 5 goes 1. And we've got remainder 1. I'm just going to write that up just so you remember. Now what you do to turn the remainder into a decimal, we add decimal points above and below the line, and a 0 after the decimal point below. Then we put our remainder above the 0 and divide this number. If that is still remainder, we repeat the trick. So in effect here, we've got remainder 1, don't we? So we can put above and below our lines, we can put a decimal point. We're going to make our little pastel carry on. We can add a 0 here. And this is because you could add this to any number, really. Any number is 0.0000000 and so on. We just wouldn't normally write that because it doesn't mean anything. But next we've got remainder 1, so I'm just going to write that in. And now we can do 4's into 10. Well, 2 4's are 8, so you can put a 2 here, but we've still got remainder 2. So we can add another 0 and put our remainder above. And then 4's into 20, which gives us 5. So it gives us a final answer of 931.25. Right. And then we go from that as well. Let's look at just down here. We're just going to look at a couple of important rules with division. So, division rules. So all even numbers so ones ending 0, 2, 4, 6 or 8 will or can divide by 2. And what this means in effect is 2 is the only prime even number, because a prime number being a number that divides by 1 and itself. Well, 2 is the only other one because all other even numbers divide by 2. And by the same token, even numbers can only divide other even numbers. So if you've got an odd number, it can't possibly divide by an even number. It's going to end up with a decimal. Only even numbers can only divide other even numbers. Right. Now C, all numbers ending 5 or 0 can divide by 5. So if you think the 5 times table goes 5, 10, 15, 20, 25, 30, 35, 40, or 5, 0, 5, 0, 5, 0, 5, 0. So 5 is going to all numbers which end in 5 or 0. It doesn't go into any other numbers. If ever you see those, you can look out. And so the all numbers ending in 0 divide by 10. So if a number ends in 0, it can always divide by 10. Equally, if it ends in 2 zeros, it can divide by 100, 3 zeros by 1,000, and so on. But basically, if a number ends in 0, it can divide by 10. So there are other rules like this. There's clever rules, for example, learning how to divide numbers by 3. I'm not going to get into them in this lecture, but other things you could probably look up. You could probably Google if you wish to find them. I'm just going to write a little bit below this actually just to explain one full thing. So I'm going to scroll down in a second here. So basically, if you need to divide by a very big number, I should say without a calculator, one trick you can often use is to simplify by dividing the numerator and denominator by the same amount. If you do this, the answer will remain the same. So just like 2 divided by 1 equals 2, if you times them both by 2, 4 divided by 2 equals 2, 8 divided by 4 equals 2. As long as you divide both numbers by the same amount, with division the answer will stay the same. So yeah, let's give an example of a question here. Yeah, say we've got 7, 6, 4, 5 divided by, and let's say 160. So straight away that looks very intimidating without a calculator. But remember in our rules we've discussed above, we can say A, both numbers end in a 0, so divide by 10. We can therefore cross out a 0. So basically, we don't need to do any calculation here. We can just do that. That leaves us with our new questions. We've got 764 divided by 16. Well, maybe we still don't love our 16 times table. I don't think many people do. So what can you do now? Well, B can say both numbers are even, and so are divisible by 2. So we could do that just to make our question easier. Well, if we do 2's into 764, nothing wrong with right now, quick bus stop. We get 3, remainder 1, 8, 2. So we get 382 divided by 8. And now we've done that, we can just do this question. So we can do 8 into 382. We could even simplify further if you wanted to, because both these divide by 2, but there's no need. But we can do 8 into 3, which gives us 0, remainder 3. 8 into 38, which gives us 4, remainder 6. 8 into 62, which gives us 7. 7 eighths of 56. Remainder 6, which we can rewrite out as we haven't been told how to give our answer, so we can put our remainder over our denominator, and we can even divide this again because they both divide by 2, so equals 47 3/4. So you see, this is a method you can sometimes use, simplification, to put what looks like an almost impossible question and put it into a method that is manageable even if you don't have a calculator. All right, so next thing we're going to talk about today, I'm just going to give a little, it's going to be a quick note. It's not going to be the prettiest notes in the world. So it was one I was using earlier today with a student. I'm just going to copy them over to our whiteboard. And we're going to talk very briefly about negative numbers. And I know negative numbers, it's not a topic in its own right, but it's an area a lot of students struggle with. A lot of people just do not feel confident, and it's something I would really recommend practicing if you feel like that, because it plays into lots of different areas of maths. And what I would recommend, if you're not confident with negative numbers, try to create your own practice questions, just dealing with numbers, throwing negatives in, seeing if you can work out the answer, and then double check these answers with a calculator if you need to. Equally, if you think you've got it and then doubt starts coming in, always double check. The way people forget negative numbers, they start getting confused, they plow on through, they think they're going to get on top of it, they think, oh, it's better to not cheat, I'm not going to look up what the answers are. And before they know it, they've got all the rules of negative numbers confused together in their heads. All right, so we've got talking about first negative numbers with addition and subtraction. And you'll see on the left, I've drawn this out with a number line. But basically, this is with one sign in the middle. So if you've got a plus or a minus in the middle. Now, if you've got a plus in the middle, your number is always going to go up. And so in effect, if it's drawn as a number line, it's always going to go up the number line because it's always going to become a bigger number. Like -3 is a bigger number than -5. So if you're going up, it's going to go up the number line. So here we've got, for example, -3 plus 7. You can see that means it goes 7 spaces up the number line and it equals 4. It's actually the same -3 plus 7 as doing 7 take 3. Then you would start at 7, you'd go 3 places down the number line, and you would end up at 4 as well. But if a plus is in the middle, you always go up the number line. Equally, if it's a minus in the middle, it's just one sign, you're always going to go down the number line. So you can see we've got the -2, take away 5. So it means it goes 5 places down the number line. So -2 take 5 equals -7. And when you've got a situation like that, it's actually the mirror. -2 take 5 is like the mirror of 2 plus 5. 2 plus 5 is 7. -2 take 5 is -7. Equally, 27 plus 12 is 39. So -27 take 12 will be -39. Now, the mirror of each other. If you can get on top of that, it's an easy way to make the sums a lot easier within the head, to make it easier to understand. If that's going to confuse you further, don't worry about the mirror aspect to it. But yeah, that's that to add as well. So basically, if there's one sign in the middle with addition and subtraction, plus always up the number line, minus always down the number line. Plus always going to lead you to a bigger number, minus always going to lead you to a smaller number. Now, you could get a question, you see it often, for example, in areas like when we get to simultaneous equations, when you've got multiple signs, you see it sometimes in different areas, where you might get 2 signs in the middle. So you might get plus -2 or plus -2. Well, if you get this, the 2 signs cancel each other out. So we think the add would take you up the number line, but then if you add in a minus, it flips it back round. So adding a minus means you take away. The 2 signs are different, you take away. So 5 plus -2 is just like saying 5 take 2. It would equal 3. Equally, if you've got 2 minuses, the first minus would take you down the number line, but the second minus contradicts it. So if you're minus in a minus, it's kind of like in grammar when you ain't got nothing, it means you have got something. And so it's the same here, minus a minus, but you're actually adding. This flips it back round. So 7 minus -3 equals 7 plus 3 equals 10. So that's with addition and subtraction. One sign in the middle, plus is always up, minus is always down. 2 signs in the middle, the second sign is going to contradict the first sign. Now, next we're going to move on to multiplication, and we'll say this is multiplication, but it's exactly the same for division. The rules that apply to multiplication are exactly the same rules that apply to division. And so if the 2 signs basically in the middle, but 2 signs of both numbers. So you've got the multiplication, then you've got the 2 numbers. So if both the numbers are positive, and obviously we don't write a positive, but for a positive number, we just write the number. So 7, it means positive 7. 6, it means positive 6. If the 2 numbers are positive, well, of course, no one struggles with this, your answer will be positive. 7 6s are 42. If both signs are negative, again, they cancel each other out. Again, it's like the ain't got nothing. It's like English grammar. The 2 negatives make a positive because you've got -7, lots of -6. They both cancel each other out. So 2 signs the same is always going to be positive. Now, if the 2 signs are different, the number is always going to be negative. So if you've got 7 lots of -6, 7 times -6, it would be -42. Negative times a positive is always negative. Equally, -7 lots of 6, or -7 times 6, your answer is going to be -42. So again, we're dealing with exactly the same area here. Negative times a positive is always going to be a negative. All right. So we're going to move on from that now. This is a bit of a refresher. We're going to briefly touch on a bit of BIDMAS or BODMAS, whatever you want to call it. It's the same thing. And BIDMAS or BODMAS, what it is in maths, the way maths works, we don't just work from left to right. We work in the order of BIDMAS or BODMAS, and all of these letters stand for something. So you've got the B, which stands for brackets. So whenever you've got sum, anything that is in brackets, you do first. We've got the I, which stands for indices. Sometimes they're called orders. Either way, they mean powers and roots. So it's like squared or square root, things like that. Now, I know indices or orders are not everyday words, but I guess if they called it like bupadamas, it doesn't sound so good. So these are the words we're given, hence they're both used because neither of those words are that good, but they guide us as long as you can remember that one. The other ones are pretty self-explanatory because then we got division and multiplication. I always sort of pair these two together because they're basically at the same time. We got addition and subtraction and the same again. But yeah, this is the order you will do your sums in. So let's give an example of a question here. Okay, so here we got 3 times 3 squared plus 4 minus 8. So the first thing to think about straight away is what comes first. Well, it's our brackets. We got a B, and within our brackets, we have got an I. We got indices. So the first thing we're going to do is 3 squared, which means 3 times 3, so it gives us 9 plus 4 equals 13. So now we can rewrite out our question as 3 times 13 minus 8. If we look at our list again, our next thing we're going to do is multiplication. So we can do 3 times 13, which gives us 39, minus 8. Finally, we're going to do our subtraction at the bottom of our list, gives us a final answer of 31. So BibMaths in general, that is what you are going to be following. There is one slight exception to this. I'm just going to show. And this is BibMaths with fractions. I'll put the question below. I'm going to write a note above. So BibMaths with fractions. Whenever we have a fraction, we work out the numerator and denominator separately first. So we deal with the top and the bottom part separately first. So here we got our top, we got 3 times 4 minus 5. For multiplication comes before subtraction. So 3 times 4 equals 12 minus 5, which equals 7. Then on the bottom, we've got our bracket, so that comes first. So 9 divided by 3, so then we've got 11 plus 3 equals 14. Well, now we've got 7 over 14, or if you want to call it 7 divided by 14, but that can simplify because they both divide by 7 to 1 half. And that'll be your final answer. So when you've got the fraction there, you've got to deal with the top, you've got to deal with the bottom, and then once you've done that, you can then deal with the fraction itself. All right, so again, just like with all of the topics we're looking at today, we're coming through them fairly quick today, but if it is an area you're not confident on, if it's something you feel you need to work on, I recommend looking up the topic, giving it a go, doing what you can to get on top of it. Okay, but we're going to move on now and have a look at a different topic. And this is slightly more fiddly topic in some ways. It's later in the exam. We're dealing with prime factors, HCF, and LCM. So prime factors, HCF, and LCM. So what we're going to do, not LMC, it sounds like top MC, but no, LCM. Prime factors, HCF, and LCM. So before we jump into this, we're just going to deal with a bit of definitions here. So there's a few words we need to be aware of. So first of all, we've got factors. So factors are numbers which go into another number, including one and itself. And you can write these, as I often do, as factor pairs, which means the numbers which multiply together to make the bigger number. So, for example, e.g., let's say we've got factors of, let's say we've got factors of 64 equals, so you could do 1 times 64, 2 times 32, 3's don't go into it, 4's do, you could do 4 times 16, 5's don't go in, 6's don't go in, 7's don't go in, or you could do 8. Or if you're going to write as a factor pair, you could write out 8 times 8, but for now it's just 8 because it's 8 times 8. Okay, so those are factors. And then next definition, we've got multiples. Numbers in a numbers times table. So think multiplication. And multiples go on forever. Obviously, we can't write all of them, but let's say, e.g., multiples of 7 equal, well, 7, 14, 21, 28, 35, 8, 42, 49, 56, and so on. So those are factors, these are multiples. And then we've got the specific ones for these questions here, which we're going to come to. So we've got prime factors. And prime factors are a unique set of prime numbers that, if multiplied together, will make a bigger number. We can find these using a factor tree. I'm not going to draw a factor tree this second, but rest assured I will be drawing one shortly, so you will get to see what is a factor tree. All right, then we got HCF, or highest common factor. Highest common factor equals the highest number that goes into two separate numbers. So say if you've got, let's say, 8 and 12, well, both 8 and 12 are divisible by 2, but they're also, so 2 is a common factor, but they're also divisible by 4. So the highest common factor would be 4. Again, we're going to look at this in more detail. And so highest common factor is often just referred to as HCF. And then we've got lowest common multiple, the LCM, which is the lowest number in two different numbers times tables. So say if you've got, let's say you've got 2 and 6, well, they both go into 12, so the lowest common, well, actually it would be 6, wouldn't it, because 2's going to 6, so it would actually be 6 in that case. So if you had 2 and 7, well, they're both going to 14, so the lowest common multiple would be 14. And so something to note, because people get confused with this, but LCM will always be bigger than the HCF, because the smallest the lowest common multiple can be is the larger of the two numbers. The biggest the highest common factor can be is the lower of the two numbers. So the lowest common multiple will always be bigger than the highest common factor. Think of it lowest, highest, that's superlattice. It's the lowest that number could possibly be. The highest the other number could possibly be. So the lowest will conversely be always the bigger number. Okay, and so we can find LCMs and HCFs using factor trees. Again, we are going to see the magical factor tree soon, and Venn diagrams, which again we will see. So I'll just give a second on this page, and then we are going to look at a couple of examples of this. Say a couple of examples. It may just be one, but one or two examples of this. So we have got here, we have got find the HCF and the LCM of 60 and 27. So what we would do for this to work out is write a factor tree for both numbers. So you got, first of all, we have got 60 here. We put that in. And what you need to do for factor tree is think of two numbers but multiply together to get 60. It doesn't matter which two numbers as long as it works. Well, I mean, 1 and 60 doesn't get you anywhere. But as long as it's two numbers, then it's fine. Well, 60 ends in a 0. It's always the easiest way. We can just do 10 and 6. And now we carry on the same stage until we get to prime numbers. So we've got 10. 10 is not a prime number, it's even, so it's divisible by 2. So 2 and 5. 6 is also even, divisible by 2 and 3. So now we've done that, we can circle our numbers. We've got 2, 5, 2, and 3. And so we can write out 2 squared times 3 times 5. And if you got a question which said write 60 as a product of its prime factors, this would be the answer. There'd be nothing more to the question. You just get to here. In this case, we got to carry on. So now we're going to do the same trick for 27. Well, 27, you could do 3 times 9. Then you've got the 9, you can do again, you can do 3 times 3. So you've got 3 times 3 times 3, 27 is 3 cubed as it happens. You can circle our 3's because they are prime and do that. And so now we want to draw a Venn diagram. A Venn diagram, hopefully you guys are familiar, it's when you have circles and they have an intercept in the middle. Intercept in the middle. And so we put the number on each side, 60 on one, 27. And in the intercept, we put numbers which are in both factors, prime factors of 60 and 27. So in this case, we've got 1 3, because we've got 1 3 here. We've got 3 3's here, so we use one of them. And now we put the remaining numbers on each side. So we've got 3 and 3. And we got 2, 2, and 5. So now we've done that. We go we are going to find the HCF. We multiply the numbers in the intercept. Well, in this case, we haven't got any numbers to multiply in the intercept. We just got a 3 that it's sitting merrily on its own. So HCF equals 3. And then we got in general, so then we can say to find the LCM, we multiply every number in the Venn diagram once. So here we got 2 times 3 times 3 times 3 times, sorry, that should be another 2 times 2 times 3 times 3 times 3 times 5. Well, a little trick I always do to make this easier but don't have a calculator, I'm going to multiply a 2 and a 5 together because 2 times 5 equals 10, and that just means we can add a 0 on the end. And 3 times 3 times 3 we know equals 27, so we've got 2 times 27 equals 54 times 10 equals 540. Okay, so I am going to just show a couple of little pieces of terminology here you can come across. It's not actually from this question, but it's worth mentioning. So note. So the numbers in 60 n, or it looks like an n. You'll see this sign in maths. It's not exactly an n, but it's very similar. It's almost hard not to draw as an n, but you'll see it like this. So there's 60 and 27. The number is 3. And so the way I remember it, this kind of takes some weird pronunciation, but it's easier for me to remember. It's n equals intercept, or intercept. I pronounce it intercept to try and help me remember it's an n. I realise it's not the best way in the world to remember it. If you can come up with another way, brilliant. And then the numbers, the other sign you'll see in 60 27 equals 2, 2, 3, 3, 3, and 5. And so U equals universal. So in either A or B. So these are terms you could see. It might necessarily be on a question like this, but obviously write the numbers in a group A and B or A, U, B. And so remembering, if you see the N, it has to be in both groups. If it's a U, it has to be in either. Or both, either or both. And so whatever way you can remember it, I remember as intercept as in the middle of a Venn diagram and universal as in anywhere on the Venn diagram. Whatever method you use to remember it is absolutely fine. All right, well, I'm going to end it here for tonight, actually, because, yeah, no one's made it along, unfortunately. I really hope people have watched this recording, because I actually think there's some useful information in here tonight, so I hope it's not just been going out into the ether, never to be heard by anyone. But yeah, if you have watched the recording, really appreciate you sitting through it, and I hope you have found some benefit on the different topics. I don't want to squeeze anything else in because it would be rushing. I don't think it would necessarily be beneficial. But yeah, have a great day, everyone who has watched this. And yeah, hopefully next week there'll be the new recording at 7:15, hopefully with some people in it as well. So yeah, thank you very much, and bye-bye.